Hi there, in this video we're going to prove the dot product. So let's consider we have two vectors. Let's say we've got a vector B in that direction. Let's say we've got a vector A in that direction there. Okay. Now if we take our side of the triangle here and we'll call that vector D, okay, and the angle in between these two here is theta, then we can work out the length of D by using the cosine formula. Now the cosine formula tells us that the length of D squared equals the length of A squared plus the length of B squared minus twice the length of A times the length of B times the cosine of the angle between them. Okay, so that there's a cosine formula for finding the length given two sides and the included angle. And I'll probably go through that at some point, maybe do a little video of that and the snippets as well. Okay, but if we were to then look at this here, we could say that that vector D, well, that vector D is equal to vector B minus vector A, and you can see that there because remember we add vectors nose to tail. So if we take vector B and we add on the negative vector A, well, the negative vector A is vector A pointing in the opposite direction, so we're adding that nose to tail, so that's a vector pointing in that direction there. Okay, so when we add that to that, we get a vector here, okay, that points there. So that vector there is the same as that vector there. Okay, so let's get rid of some of this clutter and we'll continue on. Now I won't go through every bit of the maths, I'll leave some of it up to yourself to finish off the details because it's quite straightforward. Now if I was to write that vector, find this component here, then we're going to have, it will be vector, it will be B1 minus A1 squared plus B2 minus A2 squared plus B3 minus A3 squared. Okay, so that's the length of vector D squared, and we're saying that that there is going to equal, well, the length of vector A squared is going to be A1 squared plus A2 squared plus A3 squared, okay, plus the length of vector B, which is going to be B1 squared plus B2 squared plus B3 squared. I'll take my time here. Okay, minus, well, it's going to be 2 times the length of vector A times the length of vector B, so I'll just leave that as length of vector A times the length of vector B times the cos of the angle in between. Now this is about where I won't get through the full derivation, but you can multiply these out and that's going to be B1 squared minus 2A1 B1, okay, plus A1 squared, and that will be B2 squared minus 2A2 B2 plus A2 squared plus B3 squared minus 2A3 B3 plus A3 squared. Okay, so, and this here stays the same at this side here. Okay, so it means that we're going to have a B1 squared and a B2 squared and a B3 squared. Okay, so these B1 squared, B2 squared and B3 squared will cancel out with this B1 squared, B2 squared and B3 squared, and the A1 squared, A2 squared and A3 squared will cancel out on this side here with the A1 squared, A2 squared and A3 squared. So all you're going to be left then at this side here would be minus 2 b1 a1 minus 2 b2 a2 minus 2 b3 a3, and we're saying that there is going to equal what's left of this side here is minus 2 the length of A times the length of B cos of theta. Okay, so that there, the 2's cancel out, the minus cancel out, you're just going to be left with A1 B1 plus A2 B2 plus A3 B3 is going to equal the length of A times the length of B cos theta. Okay, so that there, we write that there as A dot B, so that's going to be A dot B, which is the definition of the, that's how we write the dot product. So the dot product here is equal to this, which is then equal to the length of A times the length of B times the cos of the angle in between. Okay, so that's the proof of the dot product, and we used that there in the proof of the Fourier series. Okay, thank you for listening. Goodbye.